All right, let's dive in. We're going to talk about something that's literally powering almost everything you do online, the relational database. Now, I know that sounds kind of technical, maybe a little intimidating, but trust me, it's built on a few really simple, super clever ideas. So let's break it down.
I mean, have you ever really stopped to think about it? How do apps and websites keep track of billions, literally billions, of pieces of information? You know, your social feed, your bank account, Netflix, all of it. They somehow manage this insane amount of data and just give you exactly what you're looking for, instantly. How in the world does that work? Well, that's exactly what we're here to figure out. Okay, so here's how we're going to do this. First up, we'll define what a database even is. Then we'll peek inside to see how it's all put together. After that, we'll cover how you talk to it, the language it speaks. And finally, we'll get to the brains of the whole operation, the system in charge.
So let's get right to it. Part 1, the foundation. What on earth is a database anyway? Okay, so the official definition is pretty straightforward. It's an organized collection of data. And that word organized is everything. It's the absolute key. We're not talking about just a random pile of files on a computer. This is data with a purpose, a system, a structure, and it's all designed to be super efficient and totally reliable.
Honestly, the easiest way to think about it is this. Picture a giant, super organized digital filing cabinet. Seriously, that's it. Every single piece of information has its own perfect spot, its own label. It's just, instead of paper files, it's holding all the bits and bytes that make your favorite apps tick. All right, so we've got our filing cabinet. Now let's pull open one of those drawers and see what the blueprint looks like. How is all this data actually laid out inside?
Yeah, this probably looks familiar, right? Inside a database, pretty much everything is stored in tables, and these look a lot like a simple spreadsheet. If you've ever used Excel or Google Sheets, guess what? You already get the basic idea. So let's get the lingo down. See the columns, the ones going up and down? Each one holds a specific kind of data, like a name or an email. In the database world, we call that a field. Now look at the rows going side to side. Each row is one complete entry. So, for example, you have all of Anna's info in one row. We call that a record. And that's the big takeaway here, the difference between the two. A record, a row, is the whole story for one thing, like Anna. A field, a column, is just one piece of the story, like email address, but for everybody. It's this simple grid that's the secret sauce. It keeps everything consistent, which means you can find stuff incredibly fast. Okay, so we have our filing cabinet. It's full of these super neat tables, but how do we actually get anything out of it? You can't just, yell at your computer, hey, find Anna's email. You need a special language. And that brings us to part 3. That language is called SQL. SQL. It stands for Structured Query Language. Think of it as the universal translator for pretty much all relational databases. It's how you tell the database what to do. Find this. Add that, change this, get rid of that. Let's go back to our filing cabinet analogy for a second. If the database is the filing cabinet, well, there's gotta be a librarian running the place, right? SQL is the exact language you use to talk to that librarian. You don't just ask for a file, you say, very precisely, could you please find the record where the name is Ben and give me the email address? It's a language made for making very specific requests. And that leads us perfectly into our last piece of the puzzle. Who is this librarian, or what is it? What's the actual software, the brains behind the operation, that's handling all our requests? Well, it's called a DBMS. That stands for Database Management System. This is the software that's our librarian. It sits in the middle, listening for all those SQL requests. It figures out the absolute fastest way to go into the tables, grab the information you want, and hand it back. It's really the engine that makes it all go. And, to get even more specific, since we're talking about these databases that use tables and relationships, the thing we're really dealing with is an RDBMS, a Relational Database Management System. It's just a special kind of database that's an absolute pro at handling those tables with all their rows and columns. And I bet you've actually seen the names of these things around even if you didn't know what they were. Like, see that dolphin? That's the logo for MySQL, which is one of the biggest ones out there. You've got others too, like Microsoft SQL Server. These are the powerhouse engines running quietly in the background of just about every website, app, and business you can think of. Okay, so let's recap the whole thing. It's basically a three-step process. Step 1, you have the table, which keeps all the data neat and tidy. Step 2, you use the language, SQL, to ask for exactly what you want. And step 3, the system, the RDBMS, is the brain that understands your request, finds the data, and brings it back to you. Table, language, system. It's a really simple but crazy powerful little conversation.
And there you have it. The big thing to remember is that a database system isn't some kind of mysterious black box. It's really just a set of logical steps, one built on top of the other. It all starts with that super simple idea of an organized collection and builds up to this amazing system that manages everything with incredible speed and accuracy.
So I'll just leave you with this to think about. Now that you know these building blocks, try to think of a part of your digital life, your social media, your shopping cart, anything that isn't built on a system just like this. It's kind of hard, right? Once you understand the basics, you'll start to see these invisible structures absolutely everywhere. Thanks for watching.